Okay, so to complete the other side of a double replacement reaction, the first thing I would suggest you do is go back and backwards cross-charge all the things that you have in your beginning half of the reaction so you know what charges you're working with when you do the other half. So what I mean by this is if you take a look at the copper, we know that the first half of each of these compounds is going to switch partners. So we have to figure out what the charge is going to be on the copper. So to do that, we can take a look at what the charge would have crossed down from the copper, and we see a 2 here. So this 2 crossed down from copper and came down here when we did the cross-charging. So that means that copper must have a positive 2 charge. Okay? And then bromine, we can do this 2 ways. We can just look at the cross-charging. There's nothing written down here, which means it's a negative 1. Or we can look at the periodic table. The periodic table tells us it's a negative 1 as well. And then aluminum, again, we could look at the periodic table and it would tell us it's positive 3, or we could just see here that there's 3 chlorines, which means that this 3 crossed down, so aluminum has a positive 3 charge, and then chlorine, there's nothing down here, and that would tell us we have a negative 1 charge, and also the periodic table would tell us. Okay, so now we've got our charges, so now let's cross them. The copper we know is going to bond with chlorine, so we're going to switch the partners, so copper and chlorine. Now we know that copper had that positive 2 charge, so let's have that 2 here. It crosses down, so we're going to have a 2 down here. Chlorine over here had a negative 1 charge, so we don't write 1, so we're good on that. And then the other product is going to start with aluminum, and it's going to bond with bromine. And again, the charge on aluminum we determined was a positive 3, so that crosses down. And then bromine, periodic table tells us is negative 1, and so nothing crosses down. So now we've got our formulas written over here. The last step is to make sure that we've got everything balanced. So if you take a look, we have, let's see, we have 1 copper here, 1 copper here, so that's good. 1 aluminum here, 1 aluminum here, so that's good. However, we have 2 bromines here and 3 over here. So because there's nothing I can multiply 2 by to get 3, I need to bring both of them up. So now that means I'm going to bring a 3 in front of this whole compound to bring bromine up to 6. I'm going to put a 2 in front of this. Okay? So now the bromines are both at 6. However, now I have 2 aluminums and only 1 aluminum over here, so I'm going to put a 2 in front of this guy. That also changes my chlorines. Now I have 6 chlorines, and so to give me 6 chlorines over here, I'm going to put a 3 there, and now I've got also 3 coppers and 3 coppers. Everything else balances out. So the last step is to assign if things are going to be solid or aqueous. So we use our flow chart, which I lost. One moment. Okay, this is my rough draft flowchart, but you guys get the point. So we've got copper chloride, so it doesn't contain NH4 or group 1 elements. It doesn't contain NO3 or any of these things. We do have a chlorine though. Okay, so now we have to fill it to yes, and it doesn't contain silver, mercury, or lead. So the answer was no, so that means this is soluble. So then copper chloride is going to be soluble, so that's going to be aqueous, AQ. And then aluminum bromide, let's take a look. Doesn't contain H4 or group 1 or any of these guys. Bromide, so we have a Br. So yes, it contains a bromide, so it's going to be Ag. So it doesn't contain any of these, so we follow it to no, and so this is soluble as well. So then aqueous as well. Okay, so both of these are aqueous. We're going to talk about this more tomorrow, but when we have both of the products are aqueous, this actually means that no reaction took place. So you could label this no reaction, okay? So let's practice that another time. Let's look at, let's see, what do we want to do? Let's look at this one. Oh wait, okay, I'm going to wait for that. Okay, and these are both aqueous because they're clear solutions before we put them together. Okay. So same thing goes. We're going to take a look at this, we're going to take a look at that, and we're going to switch partners. Here's a tricky thing. So sulfur, if we look at the periodic table, the charge on sulfur is -2. So that means that technically a -2 had crossed down here, but there's nothing written. And the only way that we could have nothing written on both of our subscripts is that if Fe had a +2, so that when they both crossed down, they had the same subscript, and we got rid of them. So really, iron here has a +2 charge. Oxygen, we know from the periodic table, is +1, and chlorine, we know from the periodic table, is -1. So let's cross these things. We've got iron. It's going to switch partners and bond with chlorine, so iron, FeCl. We know iron has a +2 charge, so that's going to cross down. And then our other product is going to be H and S, so H is going to bond, and S. Sulfur, we know from the periodic table, has a -2 charge, so we're going to write a 2 here, and hydrogen is positive, so we can leave that alone. And now we can figure out what the solid is going to be. So if we use our flow chart, iron chloride, so it doesn't contain any of these, it doesn't contain any of these. It does contain chlorine though, so we go to yes, and then it contains none of these, so we go to no, so this is soluble. Okay, so we're going to write aqueous. And then hydrogen sulfide, so let's take a look. Hydrogen is a group 1 element, but technically not. It's an exemption because it really belongs with the nonmetals, so we're going to say no. Doesn't contain any of these, none of those, none of those, none of those. It does contain sulfur, so we have to follow it to yes, and then it doesn't contain any of those though, so we go to no, and that makes this insoluble, okay? So we follow this to insoluble, which makes this a solid. Okay, so now we know that this is our solid that came out of the solution. I'll do one more example with you guys. I think you're getting it though, hopefully, by now. Let's do this one here. So we've got CaOH2 plus H3PO4. Okay, so now let's figure out what our products are going to be. So backwards cross-charging, there's two ways to do this. The periodic table tells us that calcium has a +2 charge, so we know that's +2. Hydroxide, hopefully we know this by now, but hydroxide has a -1 charge. If you didn't know that, you would have known at least that nothing crossed down, which means that was a 1 that crossed down. So that means it's -1. Over here, there's a 3 right here, which means that 3 must have crossed down from PO4, so that was a -3. And PO4, remember, is a polyatomic. It sticks together as a group. So if we had anything crossed down, it would have been crossed down outside of these parentheses. So nothing did, which tells us hydrogen has a +1 charge, but we could have known that from the periodic table. Okay, let's switch partners. So we know our front guys are going to switch. Guys, this 3 does not come over with the H. The only thing that comes over is the H alone, okay? This 3 is due to the cross-charging. A lot of people will try and write H3 over here, but it does not do that. The only time that we keep our subscripts is with polyatomics. So anyway, our calcium is going to bond with our PO4, so we're going to have PO4, and then we're going to have HOH. HOH, guys, we could write like this, but we often more commonly will refer to it as H2O. This makes water, okay? So I'm going to scratch that out. Alright, so let's take a look. PO4, we figured out, over here has a -3 charge. Calcium has a +2 charge, and so the +2 is going to cross down on the outside of the parentheses, and the 3 will cross down, so we'll have a 3 written here. So let's get rid of those charges. And then as far as water goes, oxygen in the periodic table has a -2 charge. So that -2 crossed down, and that's where the 2 comes from. And then H was +1, so that crosses down, we don't write once. So now we've got everything written out. Now let's make sure we're balanced. So our calciums right off the bat are unbalanced, so I'm going to stick a, let's see. Yeah, I'm going to stick a 3 in front of this calcium. So now my calciums are balanced, and now PO4s, I have 1 PO4 over here, but I have 2 PO4s on this side, so I'm going to put a 2 in front of this compound. And now let's see, my H's, I've got 6 H's here, because 3 times 2 is 6 H's, and I have another 6 H's here, so that adds up to 12 H's. So now I'm going to have to put a 6 in front here. So now I have 12 H's on each side. And the last thing to check are the oxygens. So I have 8 oxygens here, and I have 6 oxygens here. So 8 plus 6 is 14. So that means we're going to have 14 oxygens over here. So that's 6 plus another 8 oxygens. So we're good on oxygens as well. So this is now balanced. So without even looking at the periodic table, you guys should know that water is absolutely going to be in solution. You cannot have a solid water be created, so it's going to be liquid. Remember, water is never aqueous. It can be liquid or solid or gas only. And then the CaPO4 we need to use our flowchart for. So let's see, it doesn't contain either of these things, it doesn't contain any of those things, none of those things, none of those things. It does contain a PO4 though, so we have to say yes, and that makes it insoluble. So this guy is going to be our solid. And that should be it. So if you guys need any more help, feel free to come at lunch or just rewatch this video.